everyone, welcome to the channel. My name's Nader. In this video, we're going to go over a bunch of exercises together to practice with Clojure. In the previous video, we looked at how Clojure works, so this is just going to be a bunch of more exercises as promised to really see how this works in the real world with practical examples, since we looked at a lot of the theory before. This is a super powerful topic, so I designed these exercises in order to really start to see and appreciate what Clojures have to offer us as we add it to our JavaScript tool belt. But what I did with these exercises specifically is, since they are definitely a bit more complex and there's a lot more moving parts involved, these exercises are a little bit more handholdy, where I'm going to be giving a bit more instruction and direction as to how to actually build these things out. It's still a lot of stuff that we're going to be practicing together and a lot of things that you're going to need to do on your own and figure out. However, the purpose of these is really to also see the power behind Clojures and how we can implement them in our own code and how we can spot it in other people's code or other libraries that we end up using, and actually how these things work behind the scenes. So let's just get right to the exercises. Okay. So as with all the other videos, I have a bunch of files prepared with comments at the top of each of the files. So I have a warm-up, I have 3 exercises, and then a wonderful bonus exercise for us today. And what I'm going to do is kind of go through and explain a little bit of preamble for each of these exercises, give you maybe a hint or two, give you a chance to do it yourself. Maybe you can pause the video at that point, and then we'll go through a possible solution together. So let's get our fingers warmed up with this first warm-up together. So for this warm-up, what we want to do is create a function called createCounter, and that has no parameters, right? Then inside of createCounter, we want to create a couple things. So we want to create a variable called counter that starts at 0. We're going to use let for this because it's going to change. And then a function called incrementCounter that increments the counter variable and then logs it out. Okay, so we have 2 things inside, one number variable and one function variable. Then we want to return the function. We want to return createCounter from this, incrementCounter from this function. To test out this function, we want to kind of do something like this, right? Where we have our counter created, and note that from the previous video, we saw that this is a function that we can call. And what ends up happening is if we do this correctly and we build it up correctly using the state of this counter variable, what we'll see is a different number being logged out every single time we call this function. Okay, so once you do this as a warm-up, I want you to kind of sit back and look at the code and ask yourself, why is this considered Clojure based on what we reviewed in the previous video? So give that a shot, and then we'll go through a possible solution together. Okay, so let's start with this. We're going to do const createCounter, and this is going to be a function. So we're going to have nothing inside of this function. And then, no parameters for this function, not nothing inside. Then we want to create a variable called counter. So I mentioned we should use let for this. So I'm going to say let counter, and we're going to start it at 0. Then we want to create a function called incrementCounter. So I'm going to say const incrementCounter. This is going to be a function. And what is this function going to do? Well, it's going to increment counter by 1, and we're going to log out the counter variable after we increment it. So we can do that a few ways, right? We can do counter ++, and this is why we need it to be a let, right? Because we are actually manipulating the counter variable here. We're reassigning to it. This is the same as counter equals counter +1. And then we can console.log out the counter, right? So what's interesting here is the kind of scope differences, right? So we're logging counter out and increasing counter, but counter is in the scope of the createCounter function, not inside the incrementCounter function. So keep note of that as we're going through this example. Then what we want to do is we want to return this incrementCounter. So we're going to say return incrementCounter. I'm just putting some spacing here just so it's a bit more clear as to what's happening. So those are all the steps, right? Now we can actually test this out to see if it works. So I'm going to create my counter. I'm going to get the counter function back, and I'll explain what this is doing in a second, just so that we're all on the same page. When we call this function, right, we're going to execute this code, right? That's what calling a function does. And we're going to initialize counter. We're going to initialize a function called incrementCounter, and then we're going to return that function, or return like the variable that points to that function or a handle to that function. Okay, so counter is actually a function. All right, so what can we do with a function? Well, we can call it, right? So let's try that. We'll do counter, just a few times. Okay, do it a bunch of times. I'll open up my terminal here on the right and make sure I'm in the correct folder, and I am. And I'll say node warmup exercise.js, and look at that, right? Now that's really awesome because what's happening here is actually pretty amazing. What we have is we have counter that's being changed from the scope of this increment counter function. Even though we don't have access to the counter variable out here, if you think about it, right, counter here is a function. This is a different counter variable than this counter variable. Right? That's why we can create another variable here without getting an error, because JavaScript is saying, oh, there is no counter in the global scope, so please go ahead and use it if you want, because this counter is in a totally different scope. You can see this one's even a let, and this one's a const, so they have nothing to do with each other. This counter here in this scope, in the global scope, is actually this function, the increment counter function, right? And what's interesting is that we're calling this function and different things are happening each time the function runs, which is a bit new, right? This is definitely quite different from what we've seen with other functions, because normally when you call a function, it just executes from start to finish the same every single time. But now this function remembers what's happening up here in the state for create counter. So it actually has some memory associated with it. So when we run it every single time, something different might happen, which is happening in this case. So that's pretty awesome. Now, I want to make sure before we continue with this that you are very comfortable with this solution. Okay, really trace the code, make sure that when you're calling these functions, you can kind of recap exactly what's happening inside of this function. Okay, because these next examples are going to be building on this, and we're just going to get more and more confused if you're not happy and comfortable with these fundamentals. Okay, it definitely takes some practice. You can play with this example, change the counter around, maybe add a second one, or subtract from it, multiply from it, do different things, and see what happens, just to really appreciate but also cement that in your brain. Okay, let's check out exercise 1. Now we're going to get started to do some crazy stuff. Slowly. These are going to get more and progressively more complicated. So for this one, I want to create a function called string builder that has no parameters as well. Okay, it's not too bad. Then we want to create a string inside string builder named result, and it's going to start empty string. Okay. Inside of a string builder, we also want to create this add function, right? And this add function is going to have a single parameter called characters. Okay, so this is interesting, right? This is different already from our previous example, because now we have an argument that we can provide to this inner function. Okay, so this function, this inner function, is going to concatenate or add these characters that we provided to this result string, which is the one that's kept in the state of the string builder. We're going to return this add function, and we can actually test out our string builder like this. Now, this is very similar to how you will actually work with strings in some other languages. However, they don't necessarily use closure per se. They might use like a concept called like object-oriented programming and classes and things like that. However, conceptually, very, very similar. There's this idea of there being a state, and we're manipulating that state in order to have a different result as we call this function. So give that a shot, and then we'll go through it together. Okay, so let's create this const string builder. And this is going to be an empty parameter function. I keep saying empty function, but we're going to put stuff in the function, but the parameter list is empty. And then we want to, inside of the string builder, create a result string that starts off as an empty string. So we're going to say let result equal an empty string. Perfect. Then we want to create a function called add that has a single parameter called characters. So we know how to do that. Add, we'll call this characters, and then we can have that be a function, right? So that's step 3. but we need to kind of do this part of step 3, which is this function is going to add or concatenate the characters to the result string and then return the result. All right, so this is definitely quite different. So let's do the concatenation first, right? So how do we add to a result? Well, we can do that actually in JavaScript pretty easily with the plus equals. And we can just add the characters to this result because we're using let over here for the string. Then it's saying we want to return the result. Okay, so let's return the result. It's interesting. And then we want to return the add function from the string builder. Okay, so then we want to return add. All right, so that's pretty much it actually for this function. So let's just take a look at this really quick before we actually start using it. So the differences here are that the state is a string now, right? In our warmup, the state was a number, but fine, that the state is a string. So in this case, what we're going to be doing is taking some characters and we're going to be adding it to the string. But this is different, right? We're able to actually give this function some arguments now, right? If you look at this example here, counter, we weren't giving it any arguments, right? Because as we defined it right here, because this really is counter, this increment counter, it doesn't have a parameter list, right? There's no arguments that we can pass it that are actually going to be used. So this is different because now we have one parameter in our parameter list. So we can actually give this function this argument. And we're going to be assuming it's a string and adding it to the result. But also we're going to be returning that result. So when you first see this code, and I know when I first saw this code myself, I was quite confused, right? Because I was like, okay, well, we have a return here, but then we also have a return here. Okay, so I would encourage you to really take your time to read this. I know I'm really stressing this, but it's so important because if you can also understand these small nuances in how this is just a function and we can call it like any other function. It can return values, it can ignore the return and just return undefined. We can do whatever we want in here, right? There's nothing really special apart from the fact that it also has access to this result. Okay, and then this return out here is the return for a string builder, which has nothing really to do with this add function. In fact, string builder can't actually see anything inside of the add function because it's in an inner scope. Okay, so let's test this out. So I'm going to say const builder, and also note that I can name this function that I'm going to get back from the string builder like this, anything I want, right? Technically, this builder that I've just created right here on line 31 is actually the add function, right? You can see that this is a function that takes characters and then it returns a string. Okay, so that's pretty interesting, right? We can rename this whatever we want. Now let's see if we can actually add to this. In fact, I should probably use let for this because I'm going to be, getting confused. I want to create let for the string that I'm going to create next. I'm going to say let text equal to, I'm going to call builder, and I'm going to give it my hello. Okay, so let's just test that this works for now. So notice I added a space here after the hello as well. So I'm going to run node and exercise 1. And fingers crossed, let's see what we get. I just realized I didn't actually print anything up. I always do this every single time. So I'll do console log and I'll do text. And let me try that one more time. And fingers crossed that we actually get hello. And we do, okay, right? Like that's pretty cool, right? So why is that happening? Because we're calling builder, which is calling add. Like builder is add. We're providing it characters, which is hello. And we're saying take the empty string and add hello to it and then return that string, which is hello. So hello gets stored inside of text and that's what we're logging out. Pretty cool, right? All right, so we're in the home stretch now. Now we just gotta be adding our other characters to this string. So what we wanna do here is we want to take text and effectively be able to replace it with whatever result is, right? So this result is the one that's being concatenated to. Every single time we call our add function, which we're calling builder, it's adding to this result, which is saved in the state. So we can effectively do something like this. We can say text is now equal to taking the builder, and we're going to be adding, for example, there, right? And I actually just realized that I have an error here. I'll have to correct that in the video as well. I'm doing a concatenation here. But I don't actually need to do that because I'm doing the concatenation right here, right? So this should actually be text equals builder. I can show you what would happen if we did a plus equals. We'll probably get a double concatenation going on where we're duplicating the entire sentence, but this should be an equal, and I'll fix that in the video later on in the editing as well. So in here, we can say hello there, and then I'll say text equals. So we're effectively replacing the entire text here with whatever is coming back from the builder. Now, this is not really a very good string builder because we're constantly recreating a string here anyways, but that's kind of besides the point. It works very similar to how it might work in other languages to some degree, like Java, for example. So if I say hello there, and then my, and then maybe I'll say like friend, and I'll get rid of the space at the end there, and I'll put an exclamation point. This should give us hello concatenated with there and my and friend, and we're replacing text every single time. And technically, if I really want to, I could, and I'll show you actually probably at the end of this, how we can actually modify this so it looks a little bit nicer. So I'm gonna run this and we'll see that we get hello there, my friend, which is pretty great. But check this out, right? So technically what I can do is I can do this, for example. I can just call builder if I want to, and I can call builder here, and I call builder here, and this might look a little bit better where I can, I'm calling it here, right, multiple times. I'm not actually assigning it to any variable. And if I log it out here, finally, where I'm actually assigning the final result to a variable because I'm returning the entire string, now I get the completed string finally. And this is a bit closer to what we might actually get in other languages to some degree. So if I run this, we get back the same string, which is hello there, my friend. So this is being built up over here, even though we're not assigning it to anything out here. And then we kind of get this hidden state in the closure out of the string builder and log it out in the final step, which is pretty cool, right? Definitely a lot of fun with that one. So I hope that makes sense. Let's build on this example, no pun intended, and check out exercise 2. Okay, so this one's pretty fun. This one is a vending machine example. So we want to create a function called create vending machine, and that has no parameters again. Then we want to create an array inside of create vending machine that's named stock, right? So this is, you can think of as the vending machine stock. So we're going to have cola, chips, chocolate juice, and nuts, right? This is vending machines all over the place, all sorts of stuff in there. And this is an array of strings, okay? Then we want to create a number inside of create vending machine called coins, and it's going to start at 0. Okay. Then we also want to create a function inside of create vending machine called add 25. All right. And this is going to take no parameters. And what it's going to do is going to add 25 to our coins variable every single time that we call it. However, if the coins is equal to 100, what we're going to do is we're going to pick a random item from this array, and we're going to log it out. And we're going to say you got some item, right? But we're not going to remove that item from the array. Okay. But then we're going to reset the coins back to 0. So you can think of this like a regular vending machine, right? You would go in, you put in 25 cents, for example. And when you get to a dollar in this case, or 100 cents, right? You would get your item, and then it resets back to 0 so that you can have to put in another, 4 quarters or 100 cents, whichever types of coins you're putting in there. Okay. If the coins are less than 100 though, so if we haven't reached that 100 yet, we're going to print out insert and then however many more coins are needed, right? And then we're going to return this add 25 function so that we can actually use it outside in the global scope. So this is kind of what it looks like, right? That was a bit of a lot of instructions. So as an example, you can imagine it working like this. We call create vending machine. We call it. It's going to say, okay, please insert 75 more, insert 50 more, insert 25 more. Then we're going to say, okay, you got something, right? Because now you've inserted 25 cents 4 times, which is 100 cents. And you get an item, but it gets reset. So then if you try to call it again, you have to go through the 4 quarters in this case again. So definitely a bit trickier, a lot more moving parts in this one, but it's going to set us up really nicely for the next exercise. So give that a shot yourself, and then we'll go through it together. Okay, so here, let's start with our create vending machine. So I'm going to say const create vending machine. We said no parameters. So there we go, no parameters. It's going to have an array inside of it named stock, and it's going to have these items. So I'm just going to call this right here. I'm going to say const stock is equal to this array. And then we're going to say coins is going to start at 0. So I know that coins is going to change, but stock is not going to change. So stock is okay to be a const, but coins is going to be going up and down, I guess, technically back to 0. So we can say it's going to start at 0 and it's going to be a let. Then we're going to have our function, and this is kind of the core piece of this closure. We're going to say const add 25, and this is going to be a function. It's not going to have any parameters, and it's going to add 25 to coins right away. So I'm going to say coins plus equals 25. And then now we have to kind of make a decision. Did you have 100? Do you get an item? Otherwise, we're going to print out that you need to insert however many more coins. So we can say if, so let's do the case where you get 100. So we'll say if coins is exactly equal to 100, right? Then in this case, we dispense an item, right? So we reached 100, so we dispense an item. So we can say we're going to pick a random item from our stock list. So we're going to say const random index. So I'm going to generate a random index between 0, 1, 2, 3, and 4. So I'm going to say math.floor. I always forget how to do random numbers in JavaScript. Math.floor, I think it's math.random multiplied by stock.length. I think that's right. Right, so stock.length 1, 2, 3, 4, 5, and then math.random, and then math.floor times that. I think that should be good. I'll probably have to double check that. I always mix up the random indices. So let's say that we want to grab the const random item is equal to stock at the random index. Right, so we're going to pull it out of the stock array. And we're going to then log out, you got some, and then item name. And we're not going to remove it, but then we have to reset the coins back to 0. So I'm going to say console.log, you got some, and then I'm going to put the random item in here that we pulled out. And we have to reset our coins, right? So I'm going to say coins is now equal to 0 again. All right, there we go. And then otherwise, so if you don't have coins equal to 100, that means you're at 25, 50, or 75. Then we want to say insert however many more coins, right? So I'm going to do a console.log. I'm going to say insert and then something more coins. So how many more coins? Well, we always want to make sure we insert 100 minus the however many coins that we have right now, right? So if we have 25 coins right now in there, we want to insert 75 coins, 50 coins in there, 50 coins. If we have 75 coins in there, then we're going to get 25 coins. Okay, a little bit of math, but nothing too crazy, hopefully. That's just the difference that we owe the vending machine. So in this case, we want to return our add 25 function. Okay, so definitely a lot more logic happening in this function, right? If you take a look at this, we have 2 bits of state now, right? Now that we're thinking in the context of state and functions and like closure, this stock array is in the state, so it just always exists, and we're using it here, right? You can see that we're grabbing the stock. And then the coins as well, right? That's kind of a central part of this is we're keeping track of coins, we're resetting it, we're increasing it, all that kind of stuff. Okay, so let's see if we can actually get this to work, right? So we're going to create the vending machine first, and we're going to give it a bunch of coins. So we're going to say const vending machine is equal to create vending machine, right? And just to kind of show what this is, so if I run node exercise -2, I should also log this every single time. I forget to log it. I run node exercise2, and we get a function, right? So this is the add25 function, right? So notice that this function is this function right here, right? It literally is pointing to this function right here. Even though it's called vending machine, JavaScript, it doesn't really care about that. It just knows that it's pointing at this function and it's going to execute this function, which has access to this scope right here. All right. So what we want to do is we want to call vending machine. Let's see what happens if we do that once. All right. That's pretty cool. That's pretty cool, right? Now let's do it twice. And okay, we're pretty good. I really want my my chips, I guess, or cola in this case. I wouldn't mind a cola. Now we have 25 more coins, and then moment of truth was one more time. Clear my screen here. And oh, I got some chips. All right, I hope I did this correctly. Let's see, did I do this correctly? I got some juice. I got some cola. I guess I should probably log out what I'm doing. Yeah, so I do get nuts of the last item in there, and I'm getting the first item. So I think I did that correctly. I always mix up this math, but hopefully this seems to be correct. I should probably do the math with you, but for the sake of this video, I think that seems good enough. So that's pretty cool, right? Like if you just look at this, I get like really excited when I see this kind of functionality, right? Because we are calling this function. And it looks like it should just do the same thing every time, right? It's just a function. It should do the thing that it's meant to do. But this is a special function that has access to some state because it's closing over the state of stock and coins. That's where the closure comes from, right? So even though we're executing this function right here, this function has access to stock and coins, and then we can actually use that to kind of remember the previous function calls, which is pretty amazing and very different from what we had before. And you're probably thinking, okay, well, we could have stock and coins out here, but the whole point of this is that this stock and coins are hidden from us, right? We can't access them. We can't console log out stock. We can't console log out coins, right? I can't do this. I can't say console log out stock. I'll get an error, right? If I try to run this, I'll get an error that stock is not defined, reference error. Right? Because it doesn't exist in the same scope that I'm trying to log it out in. It would only work if I tried to log it here inside of create vending machine or here inside of add25. Okay, so out here, we don't have access to this. This is used a lot by library authors and framework authors and things like that to hide stuff that is not really relevant or important, the internal workings of a lot of functionality that we use day to day. Okay, pretty awesome. Let's take a look at the third exercise. Whew, this is quite a lot. So I think we're making good time here. This is great. This is great. I want to mention that this one in particular is got some new concepts in it, right? So again, quite handholdy, but also enough room for you to practice. And now we're starting to get into the realm of things that we're actually going to see a lot in kind of real world code, right? And I want you to think of, if you've done some front-end development, for example, before this, you might see this as very similar to something that's very common in the front-end world, things like React, for example. All right, so I don't want to spoil too much, but let's take a look at this example. So we want to create a function called create database. I should probably mention, I forgot here, I think I just got too excited while I was creating this example. This create database doesn't take any parameters, okay? So I'm going to say which has no parameters, okay? Just so it's super clear. Then we want to create an array called storage inside of create database with the following values. So ABC, right? Apple, banana, carrot. And then we want to create a function inside create database called add to DB that takes a single argument. This function will push the argument onto the storage array and then log out the array, right? Log out storage. Okay, so we're going to get a string or a number, for example, and we're going to just add it to this storage array right here. Okay, then we're going to create another function inside this create database function called clear DB, which has no parameters. And this function is going to clear all the elements out from the storage array which basically means just erasing them all, right? So resetting the array so that there's nothing inside of it. Now here's the really crazy part. We're going to return an array from create database with these two functions inside of it. So this is going to be an array of functions that we return from create database. The two functions that I just mentioned right here. Both of these functions have access to the storage array because it's a closure. All right. So I want you to think, how would you use this to add values to this database and then clear it out? Okay, so practice this. I left out the example just to give you a bit more room to actually try this out yourself. Initialize the database, add a bunch of items to it, make sure it's working, clear out all the items, then add a few more items and make sure it still works. Okay, so definitely more challenging. Give that a shot, and then we'll take a look at a solution together. Okay, so let's start by creating our function, const create database, and this is going to be a function, no parameters. All right, so that's step one. Step two is create a storage variable. So I'm going to say const storage is equal to this array, apple, banana, carrot. Then we want to create these two functions, add to DB and clear to DB. So I'm going to say const add to DB. And this is going to be a function. It takes a single argument. So I'm going to say item to add, for example. Okay, so it's super clear. And what is this going to do? Well, this is going to push the argument that we receive onto this storage array. So it's simply going to do this. It's going to take storage, which is this array right here. And we know how to add items to an array, right? We can do .push. And we can push the thing that we want to add to the array. In this case, the item to add, right? So if we call add to DB and we give it a new string, for example, like Kiwi or something like that, right? That would get added to the end of this storage array. Then we want to console.log out the storage array just so that we know that it's actually in there. Okay, so that's step three. For step four, we want to create another function called clearDB. And it has no parameters, and its sole job is to erase everything inside of the storage array. Okay, so how do we do that? So let's take a look. So const clear db, and this has no parameters, and it's going to do one thing. Well, what's that one thing? So now we have to figure out, how do you clear out an array in JavaScript? So there are many ways to actually do this, and there's pros and cons to all the different ways. I'm going to cheat a little bit, not really cheat, but I'm just going to go with the simplest solution. I'm actually going to change this to a let so that I can actually reassign it. And check this out. All I'm going to do is I'm going to say, now it is an empty array again. All right. And then I'm going to console log just to be really, really sure that this is clear, the storage. Okay. Now, notice that I don't have any cons or lets in here with regards to storage, right? Because I'm not redefining the storage. I'm just accessing the storage in this state. So if I have const or let, I'm recreating a new variable called storage inside of this scope. But if I just refer to storage, I'm referring to any variable in an upper scope that exists. All right, now comes the really cool part. I want to allow our user of our create database function to be able to actually do both of these things. But we need to be able to return to them these functions, right? So how do you return two things, right? We can't really do this. We can't say return add to DB and then like comma and then clear DB, right? We basically want to do this, but this is actually not going to return both of them, okay? The only way, or one of the best ways, I should say, to return multiple items is either in an object or in an array, right? Because if you think about that, we can only return one item from a function at a time, right? But we can cheat a little bit by returning an array or an object which can have multiple things inside of it. It's still one thing, but it just has other things inside of it, okay? And if I do this like this, where I surround these in brackets, square brackets, now I'm saying create an array, and the first element in that array is the add to DB function, and the second element in that array is the clear DB function. So these are pointing to these functions in memory. Okay, we're not actually moving the entire functions around. We're just passing references to the original functions around, which is super fast. Okay, so let's see if we can actually use this, which is the last step. So we're going to say const, let's go with like database is equal to our create our database. Okay, so I want to actually log out database. Let's see what we get, right? Because this is kind of curious how we're getting two things back, right? So I'm going to say node exercise3.js. Okay, so I'm getting back an array of two functions. So that makes sense, right? That's literally what we told JavaScript to do here. Now, what I'm going to show you next is I'm going to actually use a short form syntax, which is the preferred way to work with these, which is very, very common in the front end world, especially. It's actually common everywhere, including the back end. But I want you to think of certain frameworks that are very popular that you might see things like this, just as a hint, hint, nudge, nudge. So instead of just assigning this to a variable, I'm going to destructure this out. If you haven't seen this syntax before, I have a video on destructuring as well as a bunch of exercises that go exactly into this topic if you need some help with that. But what I can say is I know that this return value has two items inside of it. So I'm just going to destructure them out. I'm going to say add, and I'm going to say clear. I can also rename them, right? Because this is an array, it goes by index. So the first item is going to go into add, the second item is going to go into clear. So if I log both of these out, so if I, oh my gosh, can't spell. If I do add and clear like this, let's see what we get. Okay, so pretty much the same thing, right? If you look at this and you look at this, the only difference is this is in an array of two items. And over here, I'm actually logging out the items themselves, which in this case are the functions. So that's pretty awesome. Okay, so think about where you might see this in the front end world. Definitely pretty neat. Now we can use add, and this takes an item to add, right? VS Code helping me out over here. Let's go with Kiwi. Okay, let's see what happens if I do this. So I'm gonna run this, and there we go. We got Kiwi, right? Let's go with what else do I want to add onto here? Let's go with Mongo. And I'll add that one. Now I got Mango on there, right? That's pretty great. Now let's see if clear works. So clear doesn't take any arguments, right? It's just in this case, clear is the name that I gave it, even though clear DB is the function. I've renamed it, right? Technically, I could put DB here if I wanted to really match it up, but I'll just go with this just to show you that we can actually rename these. Okay. Now, if I do this, let me clear this out. You can see that we're adding these two items and we're clearing it out, right? Then maybe I can add. Let's go with let's add a moose to our array for fun, right? So we got rid of the fruits and now we have animals in there, and there we go, right? So this is really powerful, right? Take a look at this, right? We have the ability to have a state, and we can have multiple functions to manipulate and access that state, and we can even allow the users to use those functions. We can expose anything that we want to the user, but also hide anything that we want from the user, which is pretty amazing. The people using our create database function in this case can't actually see this storage object. They can only see it in this case because we're logging it out, right? But we can have a whole bunch of other things in here that are dealing with the state and managing it and doing all sorts of crazy stuff. And they would never know what's actually happening internally to that function, which is pretty neat. We're going to get into more of these concepts as we get into topics like object-oriented programming in JavaScript and prototypes and prototypical inheritance and things like that. But this is a pretty central premise to a lot of those topics and many others. So hopefully this is interesting to you and makes sense. Okay, now the next one I have is a bonus question. And this is actually one of my favorite styles of showing closures because first of all, it's just fun, but it's also got enough moving parts in it that it feels very real world. These are already very real world, but this one especially you can imagine using all the time. So let's take a look at this one. Okay, so I have a lot of text for this one, so let's go through it kind of step by step. we're going to be using fetch for this example, right? So if you haven't seen fetch before, I also have a video on the channel for that. So check that out if you need help with how fetch works and the fetch API works. But if you're on node less than 12, we need to actually use npm to install the fetch package, which is actually called node fetch. But if you're on 18 or higher, which is the newer versions of the LTS for node, then you don't have to import anything. But what we want to do in this is we want to create a function called Pokemon Downloader. Okay, this is going to take no arguments. So just no parameters in this parameter list. Inside Pokemon Downloader, we want to create an object called Pokemon Cache using let. Okay, so very similar to what we just did with our exercise 3, right? So we have a storage here, but in this case, we're going to create a Pokemon Cache, and that's going to be an object instead of an array. Okay. Inside of Pokemon Downloader, then we also want to create a function called download that's going to take a single parameter, which is going to be a string. Okay. This string is, this function is going to make a request out to get a Pokemon's information by name from the Pokemon API, which is located at this URL right here, pokeapi.co. Okay. So we'll pull that up in a second and take a look. I'm just going to copy that right here. Where's my copy? And we'll take a look at that in the browser. But then what we want to do is we're going to get back a bunch of JSON data, right? So we need to do the whole response and response.json and fetching of this information. So once we grab that JSON back and we parse it, what we want to do is we want to store that inside of this object, right? Inside of this Pokemon Cache object. But what's interesting about this is it's called a cache, right? And a cache means that if we have that Pokemon object already inside of the cache, when we call this function, then we don't actually need to reach out to this API to get it. We already have it saved locally, right? So what this function is going to do with that string, it's going to check to see if it's in the Pokemon cache. If it is, it's going to return the associated object value and log that it was found in the cache. Otherwise, it's going to fetch the Pokemon's JSON and convert it to an object to store in the Pokemon cache using the Pokemon name as a key and log that it needed to be fetched from the API. Wow, that was a lot, right? But we'll see in a demo and it should make a bunch more sense, or sorry, the example below should make much more sense as we look at this. It should then also return the Pokemon object that was downloaded. So for example, this might be what the cache looks like at any given moment, right? Maybe we have asked for Pikachu once and we've asked for Charmander once. That would mean that it would look like this, right? It would have two Pokemon in there and Pikachu has Pikachu's information right here. Charmander has Charmander's information right here. So if we were to ask for Pikachu again, we wouldn't actually have to refetch that information from the API. It would actually be located inside the cache. Same thing is true for Charmander, but if we ask for example, Mewtwo, we would actually have to fetch that from the API because that Pokemon is not inside of our Pokemon cache object. Okay, so then initialize this downloader and try it out with different Pokemon names. So this is what it might look like, right? We can say get Pokemon and we initialize the Pokemon downloader. Now we can use this function, which is what's being returned from our Pokemon downloader to actually do these fetch requests. So we can say Pikachu is get Pokemon Pikachu, and then that'll say Pikachu has been fetched from the API. We can log out Pikachu if we want. We can say Mew, get Mew, Mew is fetched from the API. But if we try to get another Pikachu, right, we're going to see that Pikachu is in the cache because we already asked for it before. So we don't actually have to fetch it from the API again. Okay, so this is definitely a more challenging example, but extremely powerful. And we're going to actually leverage concepts like this a lot as we go forward, both on the front end and the back end to optimize a lot of our applications and even recreate some of the tools that we see used every day inside of different types of libraries. Okay, so give that your best shot and then we'll go through a solution together. All right, so let's start by doing this. We're going to say const Pokemon downloader is equal to a function. All right, so that was step one. I guess I actually skipped step one. I should probably npm install here. So I will say, make sure I'm in the correct folder. I'm going to run npm install node fetch. I forgot to do an npm init, but it should do that for me by default. There we go. So I have this in here. You can see that if I npm install without the init, it does work. I just recommend putting an init first. But here I'm going to add type is module just so I can use the import syntax from ES6. I'm going to go back here. I'm going to say import fetch from node fetch. All right. So that was step 1, and step 2 is complete. Then inside of Pokemon Downloader, we want to create an object called Pokemon Cache using let. So I'm going to say, oops, I literally just said let. Pokemon Cache equal to an empty object. Perfect. Then we want to create a function called download that takes a single parameter, which is a string. Okay, so I'm going to say const download is equal to, and I guess this is going to be the Pokemon name, and that's going to be a function. Okay, we know that we want to return this download function from our Pokemon downloader. Right, so I'll go ahead and add that as well. Now our job is to figure out what to do in here. So let's think about this. We basically want to ask the question, have we seen this Pokemon name before? And if we know that the Pokemon cache looks like this right here, right, where the name is the key and then the value is the actual JSON object that comes back from the API, we know that we can just check to see if one of the keys in this object is that Pokemon name, right? So we want to check to see if Pokemon is in the cache, right? So we can do that by saying if the, we'll say where is it? Pokemon cache, and we can index into it using the Pokemon name, right? So this is the same thing as if I just do this if statement like this, we're going to get back undefined for something that's not there, which is falsy. So we'll fail this test. This is actually the same thing as saying if Pokemon if Pokemon cache at the Pokemon name is not equal to undefined, right? So same thing, whichever is neater for you to actually see. So we're saying if it exists in this object as a key, well, we want to fetch, we want to actually return it, from the cache. That's what we want to do, right? So that means it is in the cache. It's a hard word, cache, and return it from the cache. So I guess I have a lot of comments in here, but I probably should put this on one line. There we go, and return from the cache. Now, how do we do that? Well, this one is a bit easier and more trivial than having to fetch it, right? Because if it's already in there and we know that the value is the thing that we're interested in, well, then what we can do is we can just simply return that Pokemon cache at the Pokemon name, right? So if it exists inside of our cache, then grab the value for that key and return that object, all right? If it's not in there, I can do an else. I mean, technically, I guess we don't need an else because we have a return here, but I'll just put it as an else. What we want to do is go fetch it from the cache. Okay, so it is, in this case, not in the cache. We must fetch it. Okay, we have to go and catch it. So how do we do this, right? So let's pull up Google real quick. I'm going to search for Pokemon API here. pokeapi.co right there, first result on Google. So we saw this in the project example where we actually built this previously, but we can actually refer to this URL, for example, right? So if I ask for this URL /Pokemon/ditto, or if I change this to Mew, I will get that JSON object, right, for that Pokemon. So I'm just going to copy this, and I'm going to come in here and I'm going to paste it in. Now we could put this in many places, but what I'm going to do is I'm actually going to put I'll put a base URL is equal to that right there. Okay. So I know that this part is not going to change. So if I go back to Google, I also know this part's not going to change, right? So it's always this thing /Pokemon and then / the name. So I'm going to say /Pokemon and then /. Right? So this part is never going to change. The only thing we need to do is concatenate the name of the Pokemon to the end of this, and we can get the Pokemon's URL for that specific Pokemon, right? So instead of having to put this down here, I'll just put it up there since that's not going to change. So what do we want to do? Well, we want to fetch this Pokemon. Okay. So in this case, what we can do is do a fetch request using our fetch package, right? So I can then say fetch. And in this case, since we're doing async stuff in here, I can either use the .then syntax and catch syntax, or I can turn this into an async function. So I'll go with the async function approach here, where I'll create download as an async function so that I can actually use await inside of it. Okay. That doesn't mean that Pokemon Downloader has to be an async function. Just this inner function can be an async if we want. So that's also pretty cool. So inside of here, I'm going to say const, and I guess I'll go with response is equal to, I guess I have to await this fetch. And what am I fetching? Well, I am fetching the base URL plus the Pokemon name, right? Because I'm adding the name of the Pokemon, like Pikachu, to the end of this URL, and I should be able to fetch that. Now we want this as JSON, so we have to translate this into JSON. So I'm going to say const JSON is equal to await response.json. And I'm going to then log it out, just so that I can actually see that I get that value. Now I'm going to do this to start just to make sure I'm on the right track, so I'm not doing everything at once. So down here, I'm going to say const, I'll go with the same syntax I had here, get Pokemon is equal to the Pokemon downloader. Okay, I'm going to say get Pokemon. I'm going to say, let's go with Mew to start. Nice and easy to type. I'm going to run a node, and this is going to be the bonus. And if we look at that, right, that's pretty cool. That is Mew's JSON object right there. Okay, so that seems to actually work. So what do we want to do in this case? Well, we want to do two things. One, we want to say that we had to go and fetch it from the API, right? For example, I say Pikachu fetch from the API, or Pikachu was in the cache. So what I'll do is I'll do a console.log down here as well, and I'll say something fetched from the API, right? And this something here is the Pokemon name. Okay, I'll actually do the same thing for here. Inside of the cached return, I'm going to say console.log, and I'll do something here was in the cache. Okay, and this is going to be Pokemon name. Right. So now we have quite a lot going on, right? If we have the Pokemon in the cache, we return it here, we log that it's in the cache. Otherwise, we're going to go and fetch it. We're going to turn it into JSON. We're going to say that we had to get it from the API. The last step, though, is to really store it in this cache, right? Because if we don't store it in there, then this check here is never going to succeed in the future because it's going to be checking to see if it's in the cache. So we have to store it in there. So we want to store the new Pokemon in the cache. So to do that, we're going to say Pokemon cache, and we're going to index with the Pokemon name, right? So for example, Pokemon cache at Mew, right, is equal to this JSON object that we just got back, this entire thing, right? Their stats. And then we can return that JSON object so that the user can use it if they want, right? Because that's the same thing that we're returning over here. So actually what's happening is, regardless of what's happening inside this function, we're going to be returning this object, which is pretty cool. Okay. Ooh, now that's quite a lot going on in there. So let's just test to see if this works. So I'm going to run this code one more time. And we're going to say that Mew was fetched from the API. So I removed the log for all the JSON, but we can actually grab that here. So if I say const, let's just say Mew is equal to get Pokemon, I can do console.log of Mew. Right? And if I run this, you'll pending promise and Mew fetched from the API. Technically, I need to actually put this inside of an async await function, but I'm going to cheat a little bit since I know I'm in a module. I can technically put in await out here just to make this a little bit easier on myself. And if I do that, you can see that we get mu fetched from the API and the actual object. Okay, so that seems to work just fine. But the correct way to do this is really to put this inside of a function that's an async function, and then wrap that to get the actual await. So wonderful. So that's actually working. I'm going to get rid of that just to actually speed this up so that we can actually run this many times to test it out. I'm then going to do a get Pokemon, and I'll say Mewtwo, and I'll say Pikachu, right? And if I clear this and I run it one more time, we're going to say fetch from the API, fetch from the API, fetch from the API. Okay, so now what happens if I try to grab Mew a second time? What we want to see is that Mew is going to be in the cache. All right, let's see if that's true. And it looks like Mew was fetched from the API again. So this is probably a bug. I think in this case, again, this is most likely, I'm guessing, because I actually don't store it in there. So this code, this is probably good that this came up. This code is executing right away because this is all synchronous code. I didn't await any of these. So what's actually happening in this case is we're actually making 2 requests from you because this first request has not come back before this second request got executed. So this one is on its way to get Mew, but then we're asking for it again, and it was never actually got to this part where we're storing it in the cache yet. So we actually never get a chance to actually check to see if it's in there. So when we run this second Mew, we actually come back into the else clause instead of the if clause. So if I come back out here and I say const Mew again equals to await this, and I'm going to do a little bit of cheating since I know I'm in ES module, I can now pretty much be sure, hopefully my JavaScript skills are correct here, that the second Mew is going to get paused to wait. So in this case, we can see that it was, and Mew was fetched from the API, and then Mew was in the cache, Mewtwo fetched from the API, Pikachu fetched from the API, right? Now that is pretty awesome, right? Super, super awesome. What we just built is effectively something that it can remember this entire set of information that we're fetching. And it's effectively like, it is a cache, right? It's a network request cache. We are able to intercept these requests and actually store them and seamlessly kind of for the user, make it so they can't actually see this cache, right? They can't see this cache right here or the URL or any of that stuff. It's all hidden from them, but it just seamlessly kind of works, right? We can get access to anything inside of there and just request for it. And some of them will come back faster, some will come back slower. But since it's an async await, we can always guarantee that you have to use await to access this as a promise anyways. So it's just gonna feel like this second Mew came back really, really fast. And this first one maybe took a split second longer, right? So we're caching all of these Pokemon inside of our object as they come back. All right, so I really loved building out this example. I hope you found this video valuable and these exercises interesting. If you did, I'd love it if you could like the video and subscribe to the channel as well. I'd love to hear in the comments what you thought of these exercises. Were they too challenging? Did you get my hint, hint, nudge, nudge about what we are seeing when we do stuff like this on the front end specifically? Is that pretty cool? You know, when I first saw this, it was like a mind explosion. I was just like, oh, wow, that's how it works. That's so cool, right? So I hope you slowly start to get that feeling. Probably won't get it right away, but as you start working with closures more, seeing them pop up, a lot of the magic behind a lot of these technologies seems to kind of disappear slowly because you're going to be able to think like, okay, there's some hidden state inside of this and it's being used to store its information and I can't access it because the scope is different and it's inside a closure. Now, closures aren't always a solution to these kinds of problems, but they are used so often and so central to JavaScript that it really is fundamental to really get these down. Now, in the next video, I'm super excited to get to another super fun topic, which is going to be prototypes in JavaScript and prototypical inheritance. Everything in JavaScript is effectively a prototype, and it's slightly different from this concept of object-oriented inheritance, which we're also going to cover because that was kind of shimmied into the JavaScript language relatively recently. But before we get to those object-oriented and class topics, we need to cover prototypes so we can really have an understanding of the precursor and what is really built into the language of JavaScript and how it differs from truly object-oriented languages. So I really hope you like these videos, specifically this set of exercises. It was a lot of fun putting them together. I can't wait to get to prototypes next. So I'll see you in that video. See you later.